So hello again. So again, today we're going to look at inverse functions, but this time we're going to look at restricting the domain of a function. So as we saw in the previous video, not all functions are one-to-one, and we need a one-to-one function in order to determine the inverse of the function. So what we can sometimes do is if a function is not one-to-one, we can restrict the domain of the function in order to create a one-to-one function. So let's see how we can do that today. I don't know what all these colors are doing here. Okay, all right. State the restricted domain for the given function so the inverse is also a function. Okay, so again, let's have a look at the function. So if we can see what the function looks like and figure out where it is one-to-one and where it ceases to be one-to-one, we'll be able to restrict the domain. So again, we're going to graph these functions. All right, we're going to draw our axes. So here, our function y equals negative x squared plus 1 is a parabola that has been reflected in the x-axis and translated up by 1 unit. So its vertex is here at 0, 1, and it opens downwards. All right, so as we can see, this is not a one-to-one function the way it is, because when we perform the horizontal line test, it intersects the graph 2 times. However, if we were to restrict the domain, so our domain for our given function is x, where x is all real numbers. If you notice, for any value of x greater than 0 or less than 0, our horizontal line no longer intersects it twice. It only intersects it once. So suppose we were to, let's restrict our domain. Restricted domain. Not sure what's going on with the whiteboard here. Restricted domain. We're going to restrict our domain to half the real line. So again, x is a real number, but now x is, say, greater than 0. So if we consider x greater than 0, let's see if we have some space. Let's scroll over to the right here, and we'll redraw our graph. But now on this restricted domain, so again, our original function was y equals negative x squared plus 1. But our new domain is x values that are real, such that our x is greater than or equal to 0. So what does our curve look like? Again, our vertex, is at 1, and it opens downwards, but now it's only half of the parabola. So now our function is indeed one-to-one, and our inverse is also a function. All right, let's try one more. All right, so we have this function y equals x plus 2 all squared minus 3. Again, this is a parabola. Let's graph it to see what its domain looks like, or what it looks like on its domain. So we know the domain for any parabola is all real numbers, a set of all real numbers. All right. So in this case, our parabola has been transformed. So it has been translated to the left 2 units and down 3 units. So its vertex is here, say, -2, 3. And it opens upwards. Let's see, let's see where the x-intercepts are. Let's just sketch it. There you go. All right, so again, we do not have a one-to-one function. Does not pass the horizontal line test. So now let's have a look at where the axis is for our line of symmetry is for our parabola. It's actually when x equals 2. So that's our line of symmetry or axis. So if we were to restrict our domain at that point, x equals -2, then I think we might have a function, a one-to-one function to work with to give us an inverse that is also a function. So let's have a look. Let's restrict our restricted domain. Our restricted domain equals x is a real number such that x is a greater than or equal to -2. Let's scroll over to the right and see what this new function looks like with the restricted domains. We'll quickly draw it. It's not very pretty. Okay. Got our axes. Okay, so again, what was our function? Do you remember? So y equals x plus 2 squared minus 3. So our vertex is at -2, -3. Our axis is the line x equals 2. And our domain, our new restricted domain, is a set of all real numbers. So x is greater than or equal to -2. So that means our graph is actually this half. Now, okay, it's not very accurate, but this is what our graph looks like, the blue curve. So now our graph passes the horizontal line test, and so our function with the restricted domain represents a one-to-one function, and our inverse for this function y will also be a function. All right, so thank you again for watching, and if you have any questions, give us a shout, info@raisemymarks.com, or give us a call day or evening, and thank you for watching.